Hello, my name is Gwen. I'm gonna be doing my project, but first I'm gonna show my NC card. I'm no longer blonde, but that's okay. Okay, so this is my research presentation on superclusters. They are the largest known structures in the universe. Throughout this presentation, I'll explain what they are, I'll explore some subtopics that I find interesting, and discuss both negative and positive impacts on scientific advancements in this area. So, superclusters are colossal cosmic structures that are made up of clusters of galaxies that are held together by gravity. These enormous formations can stretch hundreds of millions of light years and contain thousands or even tens of thousands of galaxies. Our own Milky Way, which is a part of the Virgo cluster, which in itself belongs to an even larger structure called the Laniakea supercluster. Rather than galaxies being scattered randomly across space, we now know that the universe is organized like a vast cosmic web with galaxies and clusters and superclusters linked by long filaments and separated by empty voids. Superclusters are crucial in helping astronomers map out the large-scale structure of the cosmos and understand the universe's evolution since the Big Bang. Studying them provides insights to some of the biggest mysteries in astrophysics, such as dark matter, dark energy, cosmic inflation, and the universe's rapid expansion. I wanted to cover some of the key terms so everybody can have a better understanding of superclusters, so it's just helpful. Galaxy clusters are groups of galaxies that are gravitationally bound together. They are interconnected galaxies. Filaments are long strands of galaxies that act kind of like highways that connect these clusters. And then voids, obviously, we know are vast empty spaces with few to no galaxies existing within them. And all of these elements are what come together to form a cosmic web with a large scale of a network of filaments and nodes and voids. At the intersections of these filaments, we find dense regions known as superclusters or nodes. This web-like structure allows scientists to track the expansion of the universe, again, the evolution, the history of the universe, and like the forces that make them up. So let's take a closer look at the cosmic web. This is the largest known structure in the universe, connecting galaxies and superclusters over like unimaginable distances. Scientists discovered the cosmic about the Laniakea supercluster. It's one of the most fascinating discoveries in supercluster research. The discovery was made in 2014, and what it means, the Laniakea, is immense heaven in Hawaiian. This discovery redefined our local cosmic neighborhood by showing us that the Milky Way, along with nearly 100,000 other galaxies, is a part of a supercluster stretching over 520 million light light years. What makes the Laniakea special is how it was mapped. Earlier models grouped galaxies based on where they visually appeared, but the Laniakea, however, was defined by tracking how galaxies move. So scientists found that galaxies within the supercluster flow towards a gravitational center called the Great Attractor. This was discovered using galactic movement data from something called the Cosmic Flow 2 survey, which was a large-scale computer simulation. And essentially, this discovery transformed our own understanding of the cosmos and our place in the cosmos, showing us that we are a part of a much larger interconnected structure. So it's very cool, very interesting to me. And so I wanted to get a little bit more into the universe mapping. So a major scientific breakthrough from a supercluster research creation in 3D maps of the universe was the redshift survey. Scientists would measure how galaxies' light has been stretched by cosmic expansion to calculate the distance from us. Another project was called the Sloan Digital Sky Survey and Cosmic Flows, which have mapped millions of galaxies, revealing where they are, how they move, how they're organized into filaments and superclusters. This research involves using massive amounts of data and has driven advances in high resolution imaging, machine learning, and big data analysis. And it's something that technology has advanced to the point where we used it beyond just astronomy and in other fields, which I'm also going to talk about in a little bit. So moving on to some positive global impacts. It inspires curiosity, simply, about the universe. It encourages young people to continue being curious, and it just goes to show that whatever we thought we knew, we really didn't, which could be true still, and there's probably so many undiscovered galaxies and clusters and instances out there. I wanted to talk about the advancement of technology. Like I was saying, originally it was developed for studying space, but now it's used in other fields such as healthcare, climate science, communications. For example, tools that are used to analyze galaxy data help detect tumors in MRI scans, which is very interesting. Supercluster projects unite researchers from around the world. So efforts like the Sloan Digital Sky Survey involve scientists from over 30 countries, which promotes international cooperation. Finally, learning about superclusters gives humanity a bigger perspective of just how we're a small piece in the vast existence of the universe, and encouraging kind of some reflection on that. We're just this small little people in this massive universe. Okay, moving on into negative global impacts. Cost is a major concern. Although there have been numerous advantages of this research, cost is still a big one. Building immersive telescopes, massive superclusters, they cost billions of dollars. Some people could argue that that money could be better spent solving Earth's problems like poverty, healthcare. Of course, there's the environmental impact is another issue, such as climate change. A lot of the energy used to operate these simulations, they take up a huge amount of electricity, which could potentially be contributing to climate change if it's not powered by clean energy. Scientific inequality is another one. A lot of this advanced research is happening in wealthier countries, which is leaving out opportunities for poorer nations with fewer resources, so they don't get a chance to really participate in this discovery. And then lastly, this was also in the positive section, but I just think that it's also existential anxiety, because we are just these small like creations, it reminds us that everything's temporary. While science can expand our knowledge, it can also like challenge how we view ourselves. Um, so on that note, here are the references that I use, including some peer-reviewed journals and articles and reliable sources about the surveys. And then I hoped that you learned not only about superclusters and cosmic structures, but also the importance of science and how it affects us overall as a society. Thank you.